The section we're going to deal with is section 5.3. And here are kind of a little hit list, so it keeps me on the straight and narrow. We're going to be looking at trig graphs, and in particular, we're only going to be looking right now at the sine and the cosines. The others will come later. And we're going to find what they look like. You know, what does a typical graph of a sine function look like? What does a cosine look like as well? And then we're going to introduce you to terms like horizontal shift and amplitude and period. And then after that, we're going to look at, if you tell me enough information about a trig function, right, maybe give me a picture of it or tell me things about its amplitude and its period, and its horizontal shift, can I create a trig function? Can I actually tell you what that trig function would look like in there, and from there sketch it? And then a little thing at the end, which isn't really much of a question, but they do mention, at least in one homework question I found, and this thing called the frequency. And that's kind of where we're heading today. So let me start with the first one, which is, how do you find, well, actually, let's not start with that first one. Let's start with a guy called 0. And let's look at the graph of the sine function. Well, can you imagine that this is how you would graph anything? You start with x, and then you'd find the value of the function, f of x in this case, sine x. And you'd say, well, when x is 0, what's the sine? When x was, say, pi upon 4, what's the sine? When it's pi upon 2, what's the value? And so on. And you keep going, you get to 2 pi, and you get the value of the function. I can certainly do some of these pretty quickly. So this, by the way, is not the way you would normally do it, but this is like the first time. So I would go over here, and I just realized something I need to do. Shouldn't I always check that I'm in radians? Right, just, you know, just because that's what we use a lot. Now I'm going to do the sine function, which is basically that guy. And I'm now going to look at my window, just see where it is. I'm going to move that to, I don't know, -10 to +10. It's a good window to do. Then I'm going to do zoom 0, which is zoom to fit. And there's something you may or may not be surprised to find. That's what a sine function looks like. But let's fill in this table, because that's what it was all set up for. So second table, because I already know I've set it up before. I'm going to get rid of these answers from other questions. And there's 0. There's pi divided by 4. And there's pi divided by 2. And then I would do a whole of the other things. And then at the end, there's 2 pi. Although I'm typing in pi, do you notice it turns them into the decimal versions? So for instance, this guy is 0. That guy is about 0.707. And this one is 1. Whole of the other things, this is 0. But essentially, if you sketch a sine function, this is the basic building block for every sine x. You start off when x is 0, the sine is 0. It then climbs up to a value of 1, and that happens at pi upon 2. And then it curves down, hits 0 again, and that happens when the angle is pi. And then it curves down the way till it gets to its lowest value, which is -1, and that happens at 1.5 pi. And then it curves back up, and it gets to there again. Does that look familiar? If you've ever seen a sine curve, does that look familiar? Right. Now, the thing about the sine function is that is basically it. So why was I saying, if you return here, why was I saying lots of them? Well, if you find the sine of 2.1 pi and 2.10 pi and so on, doesn't the sine function just repeat itself forever? And if you went into the negative answers, it repeats itself forever. So the sine function is basically that building block. Imagine picking this up and then just repeating it forever. And if you go the other way, repeating it forever. Does that kind of make sense that the sine function really has one basic shape and then it's just duplicates that shape forever? So this guy is what sine x looks like. And if I wanted to do it in graph paper, wouldn't I do a whole load more numbers and I just plot all the various points until I got my shape? Now, if you do the same thing with a cosine, it will be a little bit different. When the angle is 0, the cosine is 1. And then the cosine curves down the way and it reaches 0 at pi upon 2. And then it goes down the way and it reaches its lowest value, right, at pi. And then it curves back up and it gets to 0 here. And then it curves all the way up to 1, which is here. And something quite interesting happens. I know this picture's getting a little bit messy, but if you look at the sine function shape and you look at the cosine's function shape, and can you imagine the cosine continuing forever as well, right? Aren't they the same shape? Isn't one just shifted a little bit compared to the other, right? I mean, if I take this cosine, which is green in my pen, if I shifted it pi upon 2 to the right, wouldn't it match the sine function? So there's a little property that the basic shape of a sine and cosine are the same, right? They go up and down the same kind of way. They just do it in different places, right? We go with that? Now, I've just done that with, you know, a kind of by hand using the TI-84. What I'm going to do now is hopefully show you a little bit cleaner by doing it on Desmos. I'm going to have to click on that. Are you looking? No, you're not, are you? That's the wrong screen.
That's Desmos.
Oh, what's Desmos? Oh, well, the screen I was looking at wasn't, but that's me. Right, so if you go in here and you go y equals, and you just type in, I believe it's clever enough to know when you type in sine that it's sine x, and there you go, cool. And then if I do y equals cosine x, there you go. Can you see what I'm talking about? They're the same shape, they're just like shifted one to the right. Now, if I go here and I play about with my windows, which will hit the little graph setting, and I do the x-axis and I say, just go 0. Hopefully that's it. Go 0 to 2. Is it pi? Will that work? Is it pi in the little there? I'm trying to get the notation right. I think it's that one. No. Is it capital P-I? Which combination gets you pi? Help me, guys. Is it that one? It's not taking it. Okay, if you're just going to be awkward, I can be awkward too.
I'm fairly certain in the bottom left-hand corner that if you pull up the keyboard that it's going to have the pi. I haven't used it in a while.
Oh, thank you. Right, so there we go.
Yeah, I haven't used it before either.
There we go. Thank you for that. Right, so there's 0 to 2 pi, and I'm now going to do the y value from -1 to 1. And if I close all the windows, I think you just got to get, there we are. There, can you see basically just 0 to 2 pi? That's just one big one. Now, as I kind of click on this, oh, I fixed it, that's fine. Pretty cool. Got a graph, got a sine and cosine. So let me make one of these disappear for a minute. This guy is sine x, the red one. So we're going to introduce you to some terms from 141. Can you remember the range of a function in 141? The range is basically the range in y values. For a sine function, just sine x on its own, isn't it -1 to +1? You agree? Now, the domain of a function is its usable values of x. For a sine function, isn't the domain everything? In other words, you can use any value of x you like, and you should be able to calculate a sine value for it. So I'm now going to return back to my notes and kind of use some of the things I've spoken about. So if you want to talk about a sine function, and it's the same answers for a cosine function, the range are all the values from -1 to 1, right? It goes up to 1, it goes down to -1. That's what a sine or a cosine x would do. And if you want to talk about its domain, it's all real numbers. And in interval notation, which is kind of the go-to notation right now, everybody, the domain is -infinity to infinity. So we've just kind of introduced you to what a sine function looks like. They have the same shape as a cosine, they're just shifted. They both have the same range, they go from -1 to 1. And the domain is any value of x will work. You can get a sine and or a cosine in that range. So I guess that's 0. Take that out now. And we'll now do, oops, that's a bit messy. We'll now do number 1. So how to find the amplitude and the period of a sine function? You don't just get, x squared, right, in 141, right? You get 5x squared and a half x squared and -4x squared, right? Things like that. Well, you don't just always get a simple sine function. You are much more likely to get a sine function that, say, looks like that. And we have terms called amplitude and period that you would use in describing this particular version of the sine function. So first guy we're going to look at is called the amplitude. And the amplitude in this question is 3. The amplitude basically would be, if I drew that function, right, 3 sine x, it would go up as high as 3 and it would go down as low as -3, right? So the amplitude is a number that kind of tells you how stretched vertically the shape is, right? How high does it get to? How low does it get to? So 3 means it goes as high as 3 and as low as -3 in this situation, at least. Now, the second fella is called the period. So I think I draw a little picture on these because it's a very visual kind of thing. You see what the amplitude tells you? 3 to -3, right? It tells you how high it goes, how low it goes. Now the period is calculated when you're talking about radians by doing 2 pi, right, divided by that number. So whatever that number there is, right, goes here. In this case, it's pi. So what the period tells you is, if you imagine this as a typical sine function, it starts at 0 and it finishes at pi. That distance from start to finish, that's what we call the period. And from here to there, and obviously from here to here is the same thing, but we tend to like it positive. We call that the amplitude, right? Now, amplitude's easy. That number is your amplitude, and it has to be positive. We'll show you one where you would have to do that. The period is a simple formula. It's 2 pi divided by the coefficient of x. So if that was 4, it would be 2 pi divided by 4, right? If that was 6, it would be 2 pi divided by 6. So far, so good? Cool. Now, let's let's jump back to the picture and do some examples of changing the amplitude and showing you the effect of that, right? So I'm going to take sine function. I'm going to copy it down here. And I'm going to change the amplitude to 3. And oh, I'll have to go back here now, unfortunately, because I went and fixed the axis. So I'm going to change that axis, keep that one. Let's just make them all vary right there. That's no restrictions on the MID. That's probably easier for me. Nah. Can you see what a 3 sin x does compared to what a single sin x? Isn't it the same shape, but it just goes up to 3 and down to -3? Do you see that movement? Right. Now, if I make that go away, and we take this function here, and this time I'm only going to alter that guy. And probably should zoom in a little bit here. It's a little bit less obvious what that's going to look like. I may have to change the window so you can see it. Oops, didn't mean to do that. Right, now, the red one that you're looking at is sin x. Do you see that it takes from 0 to 2 pi for the sin x to repeat itself, right? So the period of sin x is 2 pi, right? From start to finish takes 2 pi from here to here. Do you notice that the blue one, which is the sin of 2x, you see it only goes half that distance till it repeats itself, and then it does another one. You see that? So if I change this to say 4, do you see that you now get 4 of them in the same cycle that sin x takes to do 1? Can you see what that 4x kind of does? It repeats it. Applications. Do you know sound waves, right? When they measure or they look at sound or any kind of radio waves, don't they look like those things there?
Yeah.
Right. So that's the, that's the one of the uses. Light, although you wouldn't think about it, light is those waves as well. The waves on the sea are those waves. So sines and cosines do get used in modeling, right? Making formula that describes sound and radio and light and the sea waves and anything else that's in it. The minute they stick the word wave at the end, it's probably going to be a sine or cosine, right? Are we visualizing a little bit what that looks like then? What the difference between amplitude is? It's just big and small, right? Up and down. That's all amplitude tells me, right? If that was a sound wave, do you know up would mean loud and down would mean low? So if the amplitude was 4, right, it would be okay. But if it was 400, you tuck your ears. But don't they use the word amplitude in the people are into sound? Is amplitude a term that you would use if you were talking about music? Is that a term you would have heard? I get a feeling that that is the term that they sometimes use. That's where that comes from, if you're interested. Yeah?
I think so.
Yeah. As far as I know. I could be wrong, but I think so. So far, so good. So if I give you a sine or a cosine function, the amplitude is connected to this number, and the period is simply take 2 pi and divide it by that coefficient now. Now, just so you don't get too caught up with the wrong idea. What would the amplitude be this time?
Would it just be 10?
It's still 10. So isn't the amplitude the positive numerical value, right? Amplitudes are always positive, right? Because won't that one also go up to 10 and down to 10? If you put that into Desmos, it would go up to 10 and down to -10. It would look a little bit different, but it would still do that. Well, let's look at what the period of this one was. The formula for the period is 2 pi divided by that number. And then you make it look pretty. So that would be what, a half pi? So can you imagine from 0 to half pi, it would do its whole thing, then it would do it twice, then it would do it 3 times, and finally it would do it 4. So wouldn't that get 4 graphs in the same distance that 1 sine x would live in, right? 1 sine x, this would be 4x. Let's be sneaky about things. What do you think -4 does, if anything, to the period?
It makes the half pi negative.
It makes sense that it would do that, but the answer is it doesn't.
Okay.
Do you notice that negatives have no effect on the amplitude and neither on the period? Because amplitude and period are always positive. Does that make sense now that we've got the rule? They're always going to be positive things. The reason why you can get away with it is a bit like the amplitude. Well, you could say the amplitude of -10 meant it went down 10. But if you go down 10, don't you also go up 10? So isn't the amplitude still 10? Right? Now, if you said, well, what about a period of -2 pi? Well, that would kind of mean you went this way. You'd be drawing your sine function over here, right? But wouldn't it be the same when you drew it this side, right? Because, you know, it has the same shape both directions. So I don't know if that's a convincing argument, but positive and positive is where you go.
I have a question.
Yes.
So, but if it's negative next to the x, doesn't it like flip it across?
Oh, it does that way, yeah. You're quite right. If you stick a negative here, your sine function gets, as you call it, flipped, reflected in the x-axis.
Yeah.
But that doesn't change the amplitude or the period of the shape, so it doesn't matter.
Okay.
So the amplitude it doesn't care if it's the right way up or flipped upside down. It's still got the same amplitude. It doesn't care if it's this way up or flipped upside down. It still has the same period. Because won't this shape still repeat itself from 0 to pi upon 2? Right?
Yeah, I was just making sure I remembered that right.
You remembered that, right? Any questions about that, or you feel okay? Amplitude and period getting thumbs up. I like that. So I'm trying to find some questions now. Where are we? 142. Here we go. Taking a moment to write up. Okay. So I'm just going to pick some questions to do with tell me the amplitude and period. That's all we're going to be asked right now in the ones I'm doing. So if I asked you for negative sine 2x, right? Can I just abbreviate amplitude to EMP now and period to PER so I don't have to keep writing, you know, the same whole word all the time? Okay, so what's the amplitude of this?
1.
1. And if you want to get the period, isn't it 2 pi divided by 2? So the answer would be pi. Okay. Now, my ones look a bit funny there. They look a little bit less funny now. Now, they very often ask you, as a third part to this question, to draw a sketch of it. Do you know what I would do? I would go into Desmos and I would put that guy in. And guess what? Katie's thing comes right in right away. Do you see how that says negative sine 2x? Can you trust me that if you put that into Desmos, it depends on how big your window, but wouldn't that be the basic shape? Can you trust me that the negative kind of flips upside down, reflects the x? So next one. Oh, so by the way, I'm for the most part going to draw the sketch part because it takes too much time. But when you do your homework, will you just type that into Desmos, look at your picture, and they give you a choice of 4 and you pick the one that looks like yours, right? That's kind of how it works. Is that okay for me to do that? Or you want to see me doing it once?
I think it's all good.
Okay, so you just play Desmos. You might have to shrink the window or stretch it because you know the scales are always a little bit different. But that's about the only thing. I don't see anything with that one. Let's try this one. This is question 3. It's 3 times the cosine of 1/4 x. Amplitude period, and then graph it. Okay. Amplitude, that's the E. As to me, the amplitude's dead easy. I don't even need to do any work and it's in front of me. But nonetheless, what is the amplitude?
3.
3. Now the period, yeah, that can be messy. Isn't it 2 pi divided by a quarter? Fractions, especially when you're dividing by them, you can sometimes make some really weird mistakes, as I have. So I'm going to do it right now. I'm going to go 2 divided by, oops, brackets 1/4. And the answer you get is 8. Did that surprise you? 8 pi. Yeah, did that surprise you? Well, now that made sense to me. Right. I was about to do this. I don't know if the calculator can handle it. Oh, do you see when I did it that way, it gave me the wrong answer?
It registers it as 2 divided by 1 divided by 4.
Yeah, it's all to do with order of calculation. So I'm kind of happy that I did the top one. Do you see how even little brackets that you don't think matter actually do matter? So if you want to do 2 divided by 5/8, do you see you would put a bracket round the 5/8? And when you hit answer, you're going to get that guy. But then you just go math number 1, which basically says turn my answer into a fraction, and that would be the period, 16/5 pi. Think this is going good? You all feel comfortable? Amplitude, period.
I'm understanding it, which is saying something.
Oh, don't be so cruel on yourself. Right. Yeah, I'll do this one because it just looks funny. Don't know why it strikes me as funny, but it does. Strange is a better word. The amplitude is 4. Agreed. Amplitude and period are always positive, so that's 4. The period is 2 pi divided by that guy, which just happens to be pi. So there is an example where the period is 2. Right? We good? Now, you trust me, if you sketched that, it would look something like this. Right, at least that would be part of it. You know, it continues forever in both sides. But I like to, when I draw a trig function, I just like to draw one cycle, right? Because that tells me everything I need to know. And then just realize the rest of it, you know, does whatever it does forever. In a way, that's quite a pretty sine function, isn't it? Because the numbers are nice instead of 3/4 pi and weird stuff. It just starts at 0 and finishes at 2. I kind of like that one there, seeing it. So if we are good, can we say number 1's done now? If I give you a function like this, sine or cosine, would you be able to say what the amplitude is? Would you be able to calculate what the period is? And would you be able to put it into Desmos and sketch it to see what the sketch looks like? Okay, so we're now moving on to number 2. And the second topic is horizontal shift. Try to make sure I don't misspell things. Americans are really nice to me. I'm a terrible speller. I was never good at English, and I have problems spelling sometimes. And Americans are really nice to me because if I ever misspell something, I just say that's how we spell it in Scotland, and you're also gullible, you believe me. You know that if I'd misspelt that and I'd said to you, well, that's how we spell it in Scotland, be honest, wouldn't you have just trusted me and went with the flow? Yeah, there's 2 Z's in horizontal in Scotland, right? Oh, well, that's a bit weird, but I guess that's how they spell it. Right?
Honestly, I'm not as concerned about how well mathematicians can spell because, you know, it's not their specialty.
You're right. Our things is numbers and concepts, and letters are just important, but we don't spend any real time on them.
As
Now,
long as the
horizontal-
word gets across what it means, it's fine.
I hear you. Okay, so I'm going to try and, before we get into the details of how to calculate horizontal shift, take you to 141. Right. Now I'm going to pick a very simple function because you have done this idea in 141. Can you remember transformation of graphs in 141, where you took something like x squared and you moved it left and you moved it right and you moved it up and you moved it down, and as Katie keeps on saying, you flip it upside down. The correct term, Katie, is you're reflecting the x-axis, but you know, I know what you mean, right? You flip it upside down. It kind of goes to what you were saying. Once the word tells you what it means, it doesn't matter too much, right? So flipping upside down kind of does tell you what's going on, right? So back to horizontal shift. Horizontal shift is what we call it when we take this shape and we move it left or right. That's horizontal shift. Now, if I took y equals x squared and I moved it 3 places, so it's now there. Can you remember that weird result? That the equation wasn't x plus 3, but that green one, right? It's been moved 3 to the right, so its horizontal shift is 3, is actually x minus 3 squared. Do you remember that? And how weird it looked maybe the first time you saw it? What would happen if I took a, if I got another color? I'll use green again. If I went and moved it 4 to the left, right? So it ends up here. What would be the equation of a quadratic that was moved 4 to the left?
X plus 4.
X plus 4. In your brain, doesn't that seem backwards? You would think x plus 4 would mean move to the right 4, and the x minus 3 squares would mean the left, right? I can understand when you got that, but you're comfortable now that minus means right and positive means left. Okay. Now, same thing happens when you take a trig function. So I'm going to pick the sine function because I want to. And here is the basic building block of a trig function, right? I'm not doing all the details, but you got the gist of it, right? If you take a, is your dog, is that your cat getting in the way there, Lana?
Yeah, she's been doing that all class. Sorry.
That's fine. Just wants attention, right? Now, suppose I take the trig function and I move it to the right pi upon 3, okay, which is about here. Now, we know that there's more of the trig function. I know that, but we're just interested in, you know, take the basic one and just move the basic, because if you let the other stuff get in the way, it distracts you. Can you clearly see that this shape has been moved pi upon 3 to the right? That would look like this. The original one would be sine x. The moved one would be sine of x. Now here we go. Plus pi upon 3 or take away pi upon 3. Which is it? Plus pi upon 3?
Go away, right?
It would be negative.
Isn't it for the same reason that went up here? Do you see that?
Yeah.
If you shift me to the right, this is negative. We call pi upon 3 the horizontal shift. Now, the horizontal shift is going to be the first one that we've met today that is allowed to be negative. I'm not going to draw on this picture because if I did, it would just be a mess. But I want you to imagine that I'm drawing it. If we took the blue one, right, the original sine x, but I moved it pi upon 4 to the left, right? In other words, I moved it right to there. Can you imagine the rest of it, right? But everybody is shifted. In that situation, then, the horizontal shift would be negative pi upon 4. And what would that look like? Well, it would look like this, the sine of x plus pi upon 4. Do you see that shifting to the left is a negative horizontal shift? Shifting to the right is a positive horizontal shift. But in the formula, isn't shifting to the right x minus and isn't shifting to the left x plus? Isn't that kind of back to front and upside down again? But are we comfortable about how it works? So a horizontal shift is how much you shift the shape to the right, that's positive horizontal shift, or you go left, which is a negative horizontal shift. That makes sense, doesn't it? Right, positive, left, negative. What kind of is back to front is that these pluses and minuses are the exact opposite of what the horizontal shift is. Does that make sense? Shift to the right, you see the connection, negative. Shift to the left, see the connection. Right. Let's put that into operation and see if we can. I'm going to do some nice easy ones just to get into the swing of things. And the same is true for the cosine. Right, for every single one of these questions, we are going to find the horizontal shift, and I'm going to call horizontal shift HS. Is that good for abbreviation? HS, horizontal shift. And there are 4 questions, and these are basically the simple ones. Start with this one. Positive or negative? That's basically all you need to answer, isn't it? Positive or negative pi upon 3?
Positive.
Agreed? Everybody? Yes, I agree. What's the second one? Positive or negative pi upon 7?
That would be negative pi upon 7.
Agreed. Positive or negative on the third one now? Positive or negative 2/3? Negative.
Negative.
Whispering it doesn't make it any less wrong. Right. Next one. Positive or negative 2 pi?
Positive.
Positive. I'm trying to think of the short way of doing this, trying to memorize it. For horizontal shift, isn't it just the opposite of what you see? Right? If you see a negative, the horizontal shift is positive. And if you see a positive, the horizontal shift is negative. Just trying to think of way of phrasing it, right? So isn't the horizontal shift the opposite of what you see? Is that a good way, maybe remembering it? So far, so good. Now, those are, I kept saying this, these are the easy ones, and it's true they are. Now I'm going to show you like the ultimate granddaddy version, right? The big ugly version of horizontal shift. You can, and you will, get questions that look like that. And we'll do each of the 3 things. The amplitude is always positive. So in this case, it's 3. Great. The period is 2 pi divided by that guy. So in this case, since you cannot simplify it, isn't it just 2/5 pi? Those are pretty easy to do now, aren't they? They're really, once you've done enough, they're pretty simple. What's not going to be at all obvious is a thing called the horizontal shift. Let me tell you what it's not. It's not plus pi. If that had said x minus pi, it would have been plus pi. Great. But it's not when there's a coefficient next to the x. So if this thing here is 2x, 5x, minus 7x, 3/4 x, right? If it ain't x, the horizontal shift is much more complicated thing to calculate. So I'm going to show you a little formula for doing it. If y is equal to the sine of bx take away c, right? So b in this case is 5 and c in this case is negative b. Right? So if it's the sine of bx minus c, then the horizontal shift is going to be c divided by b. So there's your formula. C, whatever that is, divided by b, whatever that is. So in my question, right, if we call this is b, and this is c, our guy is going to be c, right, divided by b. Sure, I wrote that right. Yes. And that's going to be pi divided by 5. Can you see where I got the horizontal shift? A pi upon 5. Now, all I'm saying is that that's the formula, right? If you can remember that formula, you're good to go. Some people don't like magic. They don't like, well, why did you do that? You could have done all sorts of other things. Why is it that combination and not, I know, b divided by c, you know, or some other combination? I'm going to prove it to you just once to show you that that formula works, right? So this is the long version of coming up with the same answer. You rewrite 5x minus pi by pulling out a common factor of 5. If you do that, that's what you get left. And just check it out. 5 times x, 5x. 5 times this guy gets you pi. Would you agree this is the correct thing? Do you see the pi upon 5 now? Right. Have I convinced you that this formula works, that you can get the answer without having to do this algebra? Can you imagine how ugly this algebra is going to be when that x is 3/7 x or 11/12 x? Can you imagine really ugly fractions? Aren't you then going to have a really hard time trying to do this? So isn't it better just saying that guy divided by that guy and call it good? Now, do you notice how I said it was positive? Can you see why? What would this question be if that was the only difference? What would the answer be to that question if this was a plus pi?
Then it'll be a negative.
Right. Isn't that just something you have to remember? You have to remember if it's plus or minus. And isn't that if it's the opposite of what you see, right? You see a plus, you know it's a negative horizontal shift. Are we good? Right, let's do some of these ugly ones. And while we're at it, just for completeness sake, I'll add amplitude and period, right? So we get the whole set. So let's do, I think, I know 3, call it a day after this. So it's going to be -2, the sine of 2x take away pi upon 3. That's my first one. Right. There's 3 different trig functions, and we're going to find amplitude, period, and horizontal shift in each case. So for the first one then, this one. The amplitude is 2. The period you get from this piece, right, from here. And that's 2 pi divided by 2, which becomes pi. The horizontal shift, well, you've got to remember to call that B and call that C. And so the horizontal shift in this case is positive, C divided by B, which is going to be pi upon 3 divided by 2. And I don't have time, but can you trust me, a calculator, you get pi upon 6. Second one now. So we're doing this guy. The amplitude would be 3. Use this number now to get the period. The period is 10, right? So 2 pi divided by 10. And on a calculator, that simplifies as 1/5. And then the horizontal shift is C divided by B. In this case, there's the B, there's the C. So you're going to get a positive pi divided by 10. Nothing else to do with that one. The last one, I have deliberately done as much damage as I could in one question. This guy. Right? Anybody volunteer? What is the amplitude of this function?
2.
Always positive, right? No matter what it is, it's always positive. Isn't the period also going to be positive? So in this case, it's 2 pi divided by, since it's always positive, should I divide by -2 or just divide by 2?
Divided by 2.
Yeah. I guess you could divide by -2 and then make the answer positive after you did it. No, that seems a bit messy, but I guess that would work. Now, the horizontal shift. This is the bit where you have to trust the math. And the formula says that you take C, which is pi upon 3, and you divide it by B, right? But here's the problem here. Isn't that a positive? So shouldn't this be negative? But isn't that also negative? So put that negative. Do you see that I'm using 2 negatives? And that means that the net effect is can you see that you now have a positive horizontal shift? So see, it's a little bit sneaky, isn't it? It's basically that divided by that, and remember the sign thing, right? So it's negative this divided by that. Hopefully you won't get too many like that, because they're kind of the ones that you can screw up. And almost always the mistake you make is the plus or the minus is the wrong one, right? So that's pretty easy to fix in the homework, right? If it's not plus, you make sure it's negative, but it's worth checking. That's all we have time for, so we'll